today we want to talk about a very well-known formula, which is the Pythagorean Theorem. This formula gets used to describe the sides of a right-angled triangle. So, hello and welcome back. Today we're talking about a mathematical topic once again. It's actually a fundamental relation in Euclidean geometry. And Euclid was a Greek mathematician. It states that the area of the square, whose side is the hypotenuse, so the longest side in a triangle, is equal to the sum of the areas of the squares on the other two sides. This sounds, well, maybe not really understandable, but we'll look at some graphical depictions and then I'm sure you'll understand what I'm talking about. The theorem itself is actually a subject of much debate because it was named after the Greek thinker Pythagoras, obviously. But the theorem might actually be 1,000 years older than the person it was named after. So, I guess you're familiar with the formula A times 2 plus B times 2 equals C times 2. This is used to describe a triangle with a right angle, so a 90-degree angle. A and B are the legs and C is the hypotenuse. Well, yes, so if we're taking a look at the drawing, we know that the green and the yellow squares together are as big as the blue one. There's actually something really nice called the Pythagorean triplets, so 3, 4 and 5 or 5, 12 and 13. So just in case you stumble across those terms. So in terminology we have to define another thing, which is the base. The base is the side that is opposite of the angle x, which is depicted here. Then we have the perpendicular or attitude or height, which is opposite the angle y. And the hypotenuse, we have already said that it's the longest side in a right angle triangle. And this one is opposite of the right angle, here depicted as z. Well now, of course you have to study it in school or also at university, but there are also real world applications. Apart from just determining whether a triangle has a right angle or not, or to know what the third side is. It gets used, for example, to calculate the shortest distance between 2 points, which is very useful when we're talking about navigation, or also for calculating the speed of sound waves. Furthermore, there are applications in architecture and meteorology. Another important aspect of mathematical things actually is to prove them. One of them is called the Euclid's proof. And it demonstrates via congruent triangles, which are triangles that are the same in size and shape, that the area of them is the same as for the left rectangular. And when we're putting those two rectangles together, they're equal to the area of the two squares. And here you see the respective areas depicted in red. But actually a more intuitive approach, and if you really want to understand it, it might be useful to just draw it on a paper and cut it out and to dissect and rearrange the parts. Now, we now know that A times 2 plus B times 2 equals C times 2 has to be true when there's a right angle in a triangle. So, it's also possible to make assumptions about triangles and their angles if this formula is not true. If we have, for example, A times 2 plus B times 2 is bigger than C times 2, then the triangle is acute, which means that the angles all have less than 90 degrees. Here you see two examples, how such a triangle could look like. Then for A times 2 plus B times 2 is smaller than C times 2, the triangle is obtuse. And this means that one angle is bigger and the other two are smaller than 90 degrees. Again, here are two examples. I hope this gave you maybe even more detailed overview of this topic. and that you now fully understand the Pythagorean Theorem. If you like this video, don't forget to give it a thumbs up and to subscribe to the channel to see weekly uploads on highly relevant scientific topics. If you want to see the other mathematical episodes, there is a playlist with those videos. Then see you